So hello everyone, I welcome you all in this lecture. So in this class we will study what do you mean by the manual mode. Now consider this scenario because it's an important, because I mean to say there are many standard flight controller are there, very good flight controller like Picshock and all. So you should know, you should understand what kind of mod is there inside, okay, how they are working actually, okay. So then there is so many mod is also there, like rate mode, true manual mode for example, and then stabilization mode. So there is a slight difference between there. And for example, like in a rate mode you will follow this kind of tracking kind of controller, okay, and in a stability augmented system you will find kind of stabilization type of approach, okay. So let's consider very first case, very simple one. In manual flight mode you give the stick command. For example, let's say I have a stick with me, so this I can configure as a pitch down, pitch up, okay, roll left, roll right, okay, rudder left and right, and this is a throttle rightly for, okay, that can you can configure. Now when you give the stick command, that can directly convert it into the angles and supply to the plant, okay. For example, this consider the same roll rate example. So what is the positive roll? Towards right, according to that this rule. If you are curling toward finger like this, the thumb is pointing towards the positive axis, okay. So plus 1, and what is the stick output? Plus 1 and minus 1. Plus 1 correspond to, you can say your aircraft is rolling with 100 degree per second, right, and minus 1 minus 100 degree per second. 100 degree per second roll rate. It is not that aileron is deflecting, okay, there's a difference, okay, okay. So and in fighter case that 100 can be 200, 300, okay. So plus 1 correspond to the 100, minus 1 correspond to the minus 100 degree per second. That's the one case. And let's say, how will you get max roll rate when you deflect max aileron, right? With the common sense you can tell, right? So plus 1 correspond to, let's say, plus 30 degree aileron, and minus 1 correspond to minus 30 degree. That means if this is an aircraft, if you want to roll this side, so this aileron you have to deflect downside, this upside consider to be plus 30 and roll right, okay. So that is the case. And you this deflection you directly connected to the stick. So when you take any kind of RC kind of flight, you will feel that very difficult to control, I mean to say, because your stick output is directly connected to the servos, okay. So very difficult to fly, in pilot workload will be very high. And I mean you can design just a 500-gram RC plane and you can fly. That is called true flight mode, manual mode. That means directly sticks is connected to the servos. Similarly for elevator and rudder you can map, okay. Now in a second case, the mode is called rate mode. In rate mode you will stick is connected with the rate, and that rate command will be going to the rate controller. For example, this in block diagram you can see, when you put stick left or right, that P will be commanded, full stick max command, okay, and then it goes to the gain and then physical limit, and then aileron will be delta A will be generated and it will go to the aircraft and you will take the feedback. That is the case. So that means when you are moving the stick, the rate command is generated. So here you can see the input delta A, it is not connected directly to the plant. It is having some loop that is called rate loop, okay. So So in this case, that is now you can see it's kind of tracking controller, right? Okay. And how will you select the gain? For example, using this equation only, you put aileron plus 30°, you will get max roll rate, right? And at the instant you have a P0, right? I mean to say, when you just commanded, right? Okay. Then K will be 30 but divided by 100. That can be 0.3. So simple K value you can find out. You can add D value and I value depending upon your tracking performance. Okay. If you want to less do, then in this case also, when you fly, you will feel some kind of comfortability. I mean to say, you will have a comfort zone, because stick is not directly connected to the servos. So like in my video, if you go to the integrated flight simulation video, you will see in the first case I have connected the stick directly to the servos, but later I will try to implement this one also, rate controller, and I will upload new video. Okay. All right. So this is the case. Okay. Similarly, you can do for a elevator case, radar case. Okay. Now, so when you give here Q command, you will take Q feedback, this aileron become elevator, right? Similarly for radar case. So now you can see in a rate mode, by deflecting the stick, your rate is generated and you are actually flying. So less workload you will be having compared to the last one, okay, which was the true manual mode. Now in the third, that is called stabilization mode. In stabilization mode, when you put stick instead of rate, the angle will be generated, angle will be commanded. For example, when you take a P and integrate, what you will get? Angle, right? Phi angle, right? Take a feedback phi, and here you are commanding phi command. Okay, phi command, this is phi, and actually what you can do here you can use PID controller or PI controller. Okay, right? So instead of rate, you are commanding angle. So in this case, instead of rate, you are commanding the angle. So let's say if your stick at a neutral position, okay, so when the stick is at a neutral position, the angle commanded will be 0, and when you stick like this, so that can command as a maximum bank angle. Maximum angle you have set, like for example 60°. Okay, so 60° you can command. Okay, so in this case, when you pilot release the stick, naturally the aircraft will come back to the stabilization, some kind of stabilized mode, right? So that means here what is phi in stabilization? 0, right? Level, right? For example, so that sense we are talking stabilization actually. Okay, now, and similarly for pitch case, so that means when you release the stick, the flight becomes level. For example, this is let's say this is the aircraft. The flight was this. When you release the stick, flight become natural level. Okay, so that is the beauty of stabilization mode. So when you fly, you will see there one mode is there. It's called stabilization mode. So that will reduce the workload of a pilot basically. Okay, and this is very good mode. If you are a very new beginner, try to fly on a stabilization mode. Okay, then don't think that stabilization is fully autonomous. It's just part of things you have automated. But what about the throttle? Throttle still you have a control. I mean to say, when you give the throttle, you increase the power, with the excess power you will climb. Okay, so you will not have any control on an automated manner on a altitude basically, right? So altitude is still, by increasing throttle, decreasing throttle, you can actually change. Increasing, it will increase, putting the throttle down, altitude will drop. Okay, so in stabilization stabilization mode, only roll and pitch are set as a in an automated manner. It will become level flight when you release the stick. Okay, that is called stabilization mode. Okay, so manual mode generally has a three type: true manual mode, and rate mode, and this stabilization mode, and all these three I have explained to you. Okay, and again I am telling you for selecting the gain. Okay, like this gain, if you have a max aileron deflection 30° and roll rate this 100, then you can select 30 by 100, that will be k, value will be 0.3. This way actually you can select the gain. Okay, if you are in a rate mode, if you are, I mean to say, if you are designing the rate mode and putting the stick left or right, generating the roll rate command, so how fast your response will be there, that depends upon the gain also. Okay, okay, so all right, we'll meet in the next class.